The 8/20 microseconds rating refers to the pulse duration and pulse repetition frequency of a laser. Pulse duration, represented by the 8 microseconds value, indicates the length of time the laser emits energy during each pulse. A shorter pulse duration typically leads to higher peak power and greater laser matter interaction. Pulse repetition frequency, represented by the 20 microseconds value, specifies the rate at which the laser pulses are emitted. A higher pulse repetition frequency translates to more pulses per second, resulting in higher average power. With the inclusion of pulse duration and pulse repetition frequency, the Joule rating becomes a more meaningful parameter as it provides a comprehensive understanding of the laser's energy delivery, showing the total energy delivered over a specific time. To calculate the energy density, which is joules per unit area, you can use the following formula: energy density equals total energy divided by beam area multiplied by pulse duration. For instance, if a laser has a total energy of 100 joules, a beam area of 1 square centimeter, and a pulse duration of 8 microseconds, the energy density would be calculated as follows: energy density equals 100 joules divided by 1 square centimeter multiplied by 8 microseconds, which equals 12.5 joules per square centimeter. This information helps in evaluating the laser's ability to damage materials or create ablative effects. Understanding the pulse duration and repetition frequency is very important for controlling laser output and determining its applications. By adjusting these parameters, the laser's effects on materials can be optimized. For example, shorter pulse durations are ideal for precision cutting or ablation, while longer pulse durations may be better suited for heating or welding. Moreover, the pulse repetition frequency determines the rate at which energy is delivered, which is essential for applications that require specific average power. In addition to pulse duration and pulse repetition frequency, other factors that affect laser performance include wavelength, beam quality, and power stability. The wavelength of the laser determines the type of material it can interact with, while the beam quality affects the focusability and precision of the laser. Power stability is important for ensuring consistent results over time. Understanding these parameters is necessary for successful laser use. The pulse duration is the amount of time that the laser is on, and the pulse repetition frequency is how often the laser turns on and off. The energy density is the amount of energy delivered per unit area. These parameters are used to assess the laser's potential to damage materials or generate ablative effects. Adjusting these parameters allows for optimal performance in various laser applications. It is also very important to consider the wavelength, beam quality, and power stability when selecting a laser for a particular application. In summary, the 8/20 microseconds rating provides valuable information about a laser's pulse duration and pulse repetition frequency, which are essential for understanding its performance in applications. Using these parameters helps users to optimize laser use. Always consult with a laser safety officer before operating any laser equipment. Always wear appropriate eye protection when working with lasers. Never point a laser at another person. Be aware of the potential hazards of laser radiation. Always follow the manufacturer's instructions for operating laser equipment.